Perspective Class 3 Video 3. In this video we're going to talk more about 2D vectors. In particular we're going to talk about linear combinations of 2D vectors. So let's begin with vector addition. If you have two vectors, v equals ab and u equals cd, then I can define v plus u to be equal to ab plus cd, which is equal to a plus c, comma, b plus d. Okay, so you add the numbers coordinate wise. So you add the first coordinate to the first coordinate and the second coordinate to the second coordinate. Okay, and this is called vector addition. So when it comes to vectors, you can have a scalar times a vector, and you can have a vector plus a vector. These are sort of like the arithmetic operations that you can do to vectors. We spoke about how to do scalar multiplication in the previous video, and now we're going to talk about how to add vectors. You can't really multiply vectors. There isn't really like a universal way of multiplying vectors. So we're going to focus on these two operations. So let's just start on this easier looking example. Calculate these vector additions. So 1, 2 plus 3, 4. You just go back to this definition, and this tells you exactly how to work it out. You add the first coordinate to the first coordinate, the second coordinate to the second coordinate. So this is going to be 1 plus 3, 2 plus 4, which is equal to 4, 6. And that's the answer. This next one, minus 3, 7 plus 3, minus 2. So I'm going to write it all out because I want to go slow. But if you can do this in your head, that's perfectly fine, and you can skip these steps. So this is minus 3 plus 3, minus 3 plus 3, comma 7 plus minus 2. So this turns out to be 0, 5. The next one is 12 plus 0, 4 plus 0, which is simply just 12, 4. So when you add the 0 vector, you don't actually change anything at all. Adding the 0 vector doesn't change anything. Finally, let's look at this last one, which has variables in it. Okay, so this one is much more confusing looking because it has variables, but the principle is exactly the same. Okay, so what do I have here? I have, maybe I'll write it on the next line so I have lots of room. 3a plus b plus 2a minus b. That's this coordinate plus this coordinate, comma 2b plus a plus b. That's this coordinate plus this coordinate. So exactly the same principle as before. It's just a little bit harder now because there are variables. I need to keep track of the variables. This isn't sufficient as an answer because it can be simplified. So I should simplify this. The first coordinate, how many a's do I have? I have 3 a's plus 2 a's. So that's 5a plus how many b's? I have 1b minus b. Oh, so I have no b's. So just 5a. The second coordinate, how many a's do I have? Just the 1. And how many b's? I have 2b plus b, so that's 3b. And I can't simplify this any further, so that's the final answer. Algebraically, this is how vector addition works. Now, let's just quickly look at how to interpret vector addition geometrically. Because I always like to think of vectors geometrically. In my mind, a vector is an arrow. So everything I do with vectors, I want to know what it does geometrically. Well, let's say I have these two vectors right here. So I have a, b, and c, d. And I want to know what's the geometric interpretation of ab plus cd. Well, I know that this is a plus c, comma, b plus d. And the geometric interpretation is essentially like you pick up this vector and you translate it along this other vector and then put it at the end. So like you put it there. Okay, and wherever that end point is, that's going to be the answer. So that's going to be a plus c, comma, b plus d. So I just took the left vector and I translated it, I put it on the end of the right vector. So I took this vector and I just put it here. So instead of starting at the origin, like usual, now it starts at the end of the first vector. Well, there's no reason why I needed to do it this way round. I also could have done like the symmetric thing and take this vector and put it here. If I was to do that, then it would actually line up perfectly. Okay? Like if I take this bottom vector and I move it up so that it starts there, it still lines up perfectly and you still end up pointing at the correct spot. And the vector, which is the result of the addition, is the one that goes from the origin right to the end. And now everything's a mess because you can't see my arrowheads, but you can imagine what's going on there, right? The answer is the vector which ends at this point right here. So this is the geometric interpretation of vectors. Like adding vectors is sort of just like concatenating vectors. So adding vectors geometrically, you just put one vector on the end of another vector and then you see where that results, you see where that ends up. So the last thing I want to talk about is like the culmination of everything we've been talking about for vectors. So if you have two vectors, v and u, and you have scalars lambda and mu, then I can do scalar multiplication and addition at the same time, right? I can do lambda times v plus mu times u. And this type of expression is called a linear combination of the vectors. It's just what it's called. It's called a linear combination of the vectors. And this isn't actually anything like new. You know, we know how to do scalar multiplication and we know how to do addition. And now I'm just asking you to do them both. So it's not substantially new. Okay, let's look at an example. So if v is equal to 3, 1, u is equal to minus 2, 4, and then lambda is 2, mu is minus 3, then what is the result of this linear combination? Lambda v plus mu times u. Well, I could write it all out in terms of numbers if you want. So this is 2 times 3, 1 plus minus 3 times minus 2, 4. Now this is 2 times 3, 2 times 1 plus minus 3 times minus 2, minus 3 times 4. This is 6, 2 plus 6, minus 12, which is equal to 6 plus 6, 2 plus minus 12, which is equal to 12, minus 10. And that's the answer. Okay, simple as that. This is how you do linear combinations. It's just arithmetic, step-by-step arithmetic. It's best if you don't try and jump too many steps ahead in your without writing it down. Just take it slow, do it step by step, and you'll get to the answer. Okay, so that's the end of this example, and that's the end of this video.